On the screen, I also sent this to you guys yesterday. I hope that the majority of you have Equatio working. I'm starting to want to see some of your work rather than just an answer, because when you get it back, you have no idea what you did right or wrong, right? So seeing the work helps me see if you understand it. As well, it helps you when it gets returned, where did I make the mistakes? Because in your answers coming up, you will see all the work for each of them as we progress through the week. I don't know how Friday went for you. I'm hoping well. Everything you need to know Friday was presented to you and answers provided and so forth. So hope that went well for you guys. It was geometric sequences, and today will be geometric series. So tomorrow you have a quiz on 6162, which is arithmetic, sequences and series. Wednesday you'll have a quiz on geometric, sequences and series. We'll start a review Wednesday. Thursday will also be a review class, and Friday is your unit test, and there will be no homework over the week or the break, other than you should start preparing for finals. I know you don't want to hear that, but it is a reality. All right, any questions? Things are good? All right, let's keep moving forward. In the package today, which I hope you see on the screen here, I put in the first 3 pages as review. Things seem to go fast online. I can never really check in with you if you understand the concepts or not. So tomorrow you have a quiz on 6162, which is the first 2 pages here. I threw in a couple review questions. So just to get the juices flowing, I'd like you to only do right now. Let's try this one, please. The first one. See if you can go back in time to mid last week, and can you solve that problem? Try to use your formulas and substitute and solve. I have to apologize today. I'm using a mouse. I left my writing tool at home, so my writing might be a little slower and messier. So if you didn't print it and you're wondering where the question went, it's still the same question on the screen. I just wanted to talk about today's assignment after class, and 3 options I hope you can pursue. Okay, I hope you're close to done that question. That would be one of the most basic questions we started with. So for today's assignment, I'm going to present you with 3 options when doing it. I'm going to use Equatio for the first one. You'll see on my screen how it can be done. The second one lots of you have been using is writing on your paper and sticking your answer in. And the last resort today, which if you have to because you can't get Equatio working, or you haven't invested the time, then you can just put the answer in. The problem with that is I made each question worth 2 marks. So if you put the answer in wrong, it's 0, right? If I see your work, then I might be able to give you 1 out of 2. So again, showing the work would be valuable as we move forward through this week in these forms. So Equatio is the best for doing that. So I'm gonna go through this problem using Equatio. Again, I'm using a mouse and it's pretty good. So for today, when you do the work, I hope you show your formula, and the formula you should have been using was Tn equals T1 plus D. And you'll notice on the right of my screen, Equatio does an awesome job of changing it to what it needs to be. Okay? All right, do we have our T1? We're trying to figure out T22. So we'd put a T22 here because that is what we're trying to figure out. T1 is -25. My D, what are they changing by? They're changing by +9. How many terms what am I looking at? 22. Take away 1. And on the right, it's working good for Equatio. You can monitor as you're writing. If you don't like it, you just would scribble out one of these and it disappears and rewrite it in. T22, I believe, is 164 if you do the math. So that means the 22nd term, the value is 164. And all I'd have to do here is insert the math, and it would go into the answers today, and it'll mark that if you put it in with Equatio. The other option, again, take a picture, put it in of your work. And the third one, please read. There's a few of you that don't want to read these things and how to enter your marks. You can't put spaces. Okay, it says no spaces, so just type everything in, no spaces. Otherwise, it counts it as a character and it grades it wrong, and then I have to correct it. Not a big deal. It just, if you read this more carefully, some of you, it would be a better choice. Okay? All right. So that's arithmetic sequences. These get progressively a little more challenging. You can do those after class if you want. I'll post the answers to you after we're done with our notes. All right, go to page 2. We then went on to arithmetic sequences. Okay? I guess I got to ask questions. Otherwise, it just sound like me talking. With series, Anna, what are we trying to calculate with them instead of sequences? What's the difference?
We're trying to calculate the sum.
Good. Okay, so we're trying to find what all the terms are worth when I add them. So when it comes to an arithmetic, Anna, do I worry about addition, subtraction, multiplication, or division with arithmetic ones?
We do like multiplication and division for finding the sum.
Not for arithmetic, that's geometric, okay? So we're looking for a D.
Okay.
Sorry, it was a good question, better to know, maybe I asked it wrong. But in arithmetics, they're either increasing by addition or they're decreasing by subtraction. Geometric are the other two operations. So tomorrow you're worrying about how are they increasing by addition or subtraction. So on this particular day, we ended up with two formulas. You had T at n equals n over 2, T1 plus Tn. Pardon me, that's the sum of. That's the whole point of these series. S at n. I knew something looked wrong there. So we're looking at the sum of all of the terms, and we have a short formula, or we had a longer one, sum of the terms. Still n over 2 didn't change. And your other formula was 2 T1s plus D n minus 1. A little more messy, a little longer in case I need to find a D, and these are just square brackets. Okay, so what I wanted to do on this particular one, let's take this one here and try for yourself, please, showing the steps, formula, substitute, answer. Again, we'll just do one question for review. The others you can do on your own time tonight after today's class.
Wait, what question are we doing?
This one right, maybe you don't see it. Do you see my pen moving right here? My screen?
I don't see your screen.
Okay, sorry, man. Thanks, Jack. How about now?
Yeah, I see it now.
All right, thank you, sir. So this is the page 2 of your note package, or if you're doing it by loose leaf, up to you. That's kind of the question we're hoping to do right now. Okay, so if you're not sure, obviously we're probably going to use the formula with a D in it because this one has a D. This term is subtracting by 4s is what it's saying. So we want to find S of 10 because it told us there's 10 terms. I'm going to go 10 divided by 2. Just because I'm using my mouse, I'm not writing as much today. I should be writing the formula, but the mouse is a little painful. 2 times -7 plus a -4. So I'm just going to right away go subtract 4. N minus 1 is 10 minus 1. That's a 9. All right, Aiden, what did you get for a final answer?
I got -250, but I don't know if that's right.
You are right. Good job. That is correct. Okay. Sometimes you guys are feeling like these aren't the right answers, but that's just natural because some of our sums are negative in these questions, right? So have a little more confidence. You guys are doing fine. All right, let's go to the next part, which was Friday's lesson. And geometric. Geometric has an R now, a rate. And geometric means I'm either multiplying or dividing by a rate. So if I times 2, T1, term 1 times 2, then term 2 times 2, then term 3 times 2, and so forth, okay? So this particular formula was, for you here, was Tn. Again, we're using T's and terms because this is a sequence. You use S and N's when it's a series, okay? And here R to the exponent n minus 1. And that was pretty easy for most of these questions on the first page. Sometimes we get fractions. I will say to you, as long as you're listening right now, you are better off to use this in your problem than this number, okay? So if you ever get a decimal that doesn't terminate, don't use it. Use the exact fraction. If my decimal terminates, then by all means use it because it's probably easier than a fraction, okay? Only use decimals that terminate for an R. The one question I'd like to do together is on the next page. I find these very interesting. There are 3 steps in this particular one. So this is seeing how well you did on Friday. I need you to find an R. Then I want you to find for T7. And then this area here is the big one. This is the one I want to make sure we focus on. So at least do the first 2 columns. Try to figure out R, try to figure out T at 7, and then we'll work on the last term together. How many terms are in this problem? So this goes back to Friday's lesson. Same formula. It's an R to the exponent n minus 1. Please ask questions if you're not sure who is what. I wasn't there Friday and you had a video, so if you're not sure where to start, I can start you off. Question? Okay, for those not sure, I'd probably try a T5 here. I have a T1, and I have a 5 minus 1, put in what I know. Now I'm showing divided by 1. I don't really have to do that. But that's what, if it was a different number, that's what you would do. Okay, Aaliyah, we get to this point. How do I solve for R?
You need to find the cube root of 256.
Cube root, we'll call it the quad root. So R to the 4th, we're going to take the same. So on your calculator, it's a little more challenging to do this. You have to find, I think it's the math button. So you'd have to type in 4, then you'd go to math. Whoops, got to turn it on. 4, then you would choose math somewheres. Then you'd choose the 5th function, and you'd put in 256. Okay, it would look something like that. I don't know if you see that. And then you'd hit enter, and Aaliyah, what do we get?
4.
Good, the answer, our R is 4. In other words, we're timesing our terms by 4. So please go figure out T7 now. You now know your R. Katana, I'm going to ask you what T7 is worth when you're done.
I got 4,096.
Nailed it. Good job. That's what it's worth. Well done. Okay, so this is a review of Fridays. These are geometric sequences. Today we're going to be geometric series. All right, this is my favorite type of question. Okay, we're now going to try to figure out how many terms does this sequence have if the last term's value is 65,536. All right, so let's start with our formula. This is a very high level problem. If you get this, you understand what's going on. Our goal in this problem is to figure out n. I'm going to give you a couple minutes to see how well you do on it. Anybody brave enough to give me an answer when they think they're done?
I got 17.
We got a
I got
17.
9.
We got a 9. 17.
At 9 as well.
Another 9. Okay. One of those is right. I will say that. Okay. So the last term is the 65,000. That's its value. T1, we know is a 1, which is nice for us. R, we know was a 4. And we have an n to the minus 1 because we don't know n. So if I divide by 1s, it's going to leave, right? So regardless, that's not a problem. Here's the fun part, I guess. It's called trial and error at this point for you. I need to find something to the base 4, something to the base 4, 4 to the power something has to equal that number. So I try 4 to the 6, 4 to the 7th, 4 to the 8th, and at some point I have to get that number or it's not going to work because n can't be a decimal, and I believe it comes out to 8. Once our bases are the same, we can ignore them, and now I just simply solve it. And in this case, add 1 to both sides. The answer is 9. Okay, that's as hard as it gets for a geometric series. That's a very challenging question. But again, when you get down to the same base, it's just trial and error. 4 to the what? 4 to the 6, 4 to the 7, 4 to the 8, whatever till I hit that number. And then I ignore the base and solve. And n always has to be a whole number. Okay, so the answer there was 9. Okay, so the first few pages are review if you want. Let's go on to today's lesson. Another term of geometric series, okay? So today, geometric means we are multiplying and dividing. I hope you can still see my screen. If not, let me know. And again, we're going to worry about the sum of them. Okay, so things can grow very fast. Some of you are in biology. So just think of one cell. In this particular case, one cell becomes 3. Those cells become 3. You can see how fast this grows in no time. So in other words, I'd like to know how many happy faces are in this diagram. Well, that becomes 1. I'm timesing by 3. This next row would be 9 times 3, 27. So cell growth, let's say it's cancer, multiplies very fast in this type of scenario. Or even mitosis, okay? Growth of a baby. Cells are just multiplying fast. That's how we grow, right? So it's geometric, multiplying by a constant ratio. So in today's lesson, I'd want to add all of these up to find the sum of the series. So very simple math in this one is 1 plus 9 is 10, plus 30. There's 40 happy faces on that diagram, but we want to figure out a formula to do it rather than adding by observation or calculator, okay? All right, so a geometric series is the sum of the terms. These are geometric sequences, okay? Why is this a sequence here, Rodney? Why is this one a sequence? How do I know? How is it different than the
Is it
series?
because it's multiplying? Because it's not adding it, it's just the numbers?
Yeah, it's just the numbers, right? The comma kind of gives it away. We're not asking you to add it, it's just a series. But this is the series of the same sequence, of the same numbers. Just now we have plus signs in them. So I want to add all the numbers up. Sequence, commas, series, adding or subtraction signs. But again, it's geometric because I'm timesing by the same number. Times 2, times 2, okay? So it makes it geometric. All right, so here's the formula for today. At the bottom, you'll notice that you can flip it around. Depending if R is larger than 1, I might want to use this one. If R is smaller than 1, I might want to use this one so that I don't screw up negatives. But however, I just always use this one. I just deal with my negatives. I know how to deal with them, so I just use that one. I don't worry about switching it because R is bigger than 1, but that's your option, okay? obviously R can't be 1 or we have a problem. It would be an NPV. Okay, so let's go to an example. All right, here's a series, a geometric series, and we want to take this series for 15 numbers. And what I thought, man, this is weird. How does this look? So on the right of your screen, I took those numbers and I was doing something to them. You got to figure out your R. And these are all the numbers for 15 times. And when I added it on my spreadsheet, this is what it came to, a very small number considering where we started with the 40. You'll notice the numbers are getting really, really small. Like every time I times by -2, they're going to get smaller and smaller. Okay? All right, or sorry, divide by -2 is what these are doing. So let's figure out our R. On Friday's class, I told you take consecutive terms and divide them. Okay? So I'm going to go T2 divided by T1. So -20 divided by 40. I like decimals. I find it easier to use than a fraction, but you might have been the person who wanted to use -1/2 as your R. I prefer -0.5. I just find it easier to deal with in my calculator than a fraction. All right, you take the R now and go see if you can figure out S at n for S at 15, see what you get for an answer. If you do a good job, it should match over here. Now you got to be careful with your negatives. So if I'm setting it up, I just want to make sure you set up the first one right. This negative has to be in brackets in my calculator. And it was a 15. So I have to do that first. I got to make sure this negative stays inside the brackets, and that's how it would look in the calculator. Bracket -0.5 to the 15. And on the bottom, make sure, take away -0.5 again. What does that do? So let's just make sure you're doing the math right on the top. I used a little hat symbol for exponents. So when I do the math, I get the exact, well, I'm going to round it to the tenths, 26.7. Anybody need help with the calculator in getting that answer? No? Okay, let's go to example 2. Example 2, I had a very hard time believing this question once I figured out the answer, okay? So on the right, it is representing the problem, so you kind of already have the answer. But on the right, term 1 was we're trying to figure out term 1, but in the end, we'll see that it's 2. And when I multiply by a number and I keep doing that, and I added up those 10 terms, I got a negative 29,524. I had a hard time believing it, so I had to go to a spreadsheet to show that, and you'll kind of get a better picture after you solve it, okay? So in this particular one, I want you to go solve for T1. Put in all the information you have, being careful with your negatives, solve for T1. You gotta be careful, the ratio is a negative 3. Careful with negatives. I'm going to do all the math on the right side because they're all multiplication. I can divide them, I can cancel them, whatever I need to do. And if I do a good job, I get this on this side. And you're all capable to understand T1 turns out to be a 2, exactly what I said up here. So when I times these by negative 3, that's what it was doing. And it keeps doing that, and then I add them all up, I ended up with a negative 29,524. It's hard to believe when you start with a positive 2, and after I do this for 10 times, multiplied by negative 3, that this is going to be this big, or that small, I guess. But it is. You can see by the 10th term, it's already at close to negative 40,000. Okay? So again, that's how fast things can grow geometrically. You think of Twitter and social media. I send it to 2 people, they send it to 2 people. That's how fast these things can grow. Okay? A lot faster than a sequence, an arithmetic one. All right, last one. I think it's last. No, there's a couple more. So let's go to the next page. I will give you a chance to try this one on your own. Calculate the sum of the series for this particular situation. I'm open to questions for this question because it's a little more challenging than the past one. So I will await questions if you're not sure what to do. Things I do know or don't know, I might start putting on the side. I don't know an n, could be a problem. In some regard, I know my Tn. I know my value of my last term. Do I know an R? Take a T2 and divide it by a T1. I have an R. I have a T1. Okay, so I'm going to ask Mary. Mary, this formula that you see on the screen, do I have enough information to use it or not?
I'm not sure.
Okay, I'm going to ask you a couple questions, and Mary, that's good. I'm glad you answered that. Do I have the sum? Do I know the sum of the series?
No, you're trying to calculate that.
All right. Do I know the number of terms? Do I know an n?
No, because it's missing in the middle.
Right. So when we have two unknowns, I can't do this. I can't use this formula right now. So what else could I use, Mary, to help me get into this formula? What do you think I have to do first?
Find like the number of terms.
Good. So we're going to use our first formula we learned with geometric. Tn equals T1 R to the n minus 1. Go find the number of terms. So this goes back to about 20 minutes ago. We did a class example where some people said the number of terms was 9, some said it was 17. This is the exact same type of problem. You have to figure out n. Okay, T at n means my last term. I know its value. I know my T1. I know my R. I'd like to know what someone gets for n this time.
Yeah, 12.
You got a 12. Any other answers out there?
I also got 12.
Another 12. You guys are correct. It is 12. Well done. So I'm going to divide by 6, leaving me with a 2 and minus 1. This is a good sign that I need my base to be 2. So after I divided by 6, I ended up with 2,140, I believe. Okay, we're not done because we need the bases to be the same. Trial and error will be what you got to do. 2 to the what equals 2,140. You got to try, maybe 10, 11. Looks like it's 11. 2 n minus 1. Can ignore the bases, and we get 12. All right, now go figure out the sum of 12. Because now we know how many terms were in that problem. And now we have an n. Okay, I'm just going to put the final answer there, see if you get it. Really important to keep R in a bracket and do an exponent, especially if it's negative. My screen is really small, so I'm going to ask Landon. Landon, how do I know that 12,288 is my last term? What tells me that?
Sorry?
How do you know 12,288 is the last term? There's nothing past it. What tells you that?
Because it's just the last number there. That's not, I don't know.
That's it, and that's why I'm asking it, because some people don't understand why. Why? Because there's not 3 dots behind it. It means there's numbers in here, and it stops. Okay, so to put you on the spot there, Landon, sorry about that, but the point is there's no 3 dots after it. That's why it ends there. If it continued, you'd see 3 more dots. Okay, so that gives it away. All right, so let's go to the last question. Which is a word problem. A person takes antibiotics to cure an infection. Each tablet of 200 milligrams that is taken dissolves to 12% of its size by the time the next pill is taken. Determine the mass of the total antibiotics after 3 tablets are taken and after 12 tablets are taken. Okay? Kind of a unique problem. And once we talk about it, it might make a little more sense for you. All right, so again, this is a geometric series. We're doing something to the 200 every time, 12% intent, and what will it look like after 3 tablets? So let's just draw ourselves a little picture of this, and so on. The first one's 200. Okay? At this point, I'm about to take another pill. So you just kind of figure this out. When I take this second pill, how much of the last one is there, still in my body? So Aaron, what am I doing to 200 to figure out what's left over? The 0.88 would mean it only reduced 12%, so 88% stayed behind. But this is saying that this pill actually dropped all the way to 12%. So it lost 88% of its value. It's a little bit tricky wording. So we're going to times it by 0.12, but you're on the right track. Okay? It says it dissolves to 12%. It loses 88% of its value. So when I take the next pill, essentially there's 24 grams of that 200 left in my body. And now I'm going to take another one and 200 would be added. Okay. Then it asks you to take a third tablet. Okay. By the time I take a third tablet, just figure out roughly what that one's worth in your body. From my first pill, how much is left? Okay. Again, I times it by. What's that?
So it says that happens each time a pill is taken, though, and it's asking for the total mass or whatever. So when you multiply it by 1.12?
No, because it's decreasing, not increasing. Well, you're right. This is why I'm drawing a diagram, Landon. You'll see what's happening right away here.
Okay.
It's a little confusing. So in the end, this one now is 2.88. Okay? That's what's happened to my first pill by the time I take my third pill. So pill 1, I took another pill here, I took another pill here, and by the time I do that, my first pill is worth this much, and we'll continue with the drawing after we do the math, okay? It's a confusion question for sure. All right, so what I want you to do is go calculate your rate you have. Okay? Go figure out S3 using your new geometric sum formula. Caitlin, I'm going to ask you for your answer once you solve for S3.
I'm gonna be completely honest. I have no idea what I'm doing here. The formula is just like not comprehending. My brain's not comprehending the formula.
Okay, so I'm putting it on the screen to help you here, Caitlin. We're using the same one, right?
Mm-hmm.
I have a T1, 200. I have an R, which is 0.12. And I have an N because I have a 3 here. So that tells me my N. So I have everything. I have T1 being 200. My R is my rate of 0.12. N is the number of times I've taken pills, which is 3. I hope that helps you. If someone gets an S3 value, please share it.
Isn't it n minus 1?
N minus 1?
Yeah, like on the formula.
Nope, not on this one. Not on the sum series. Yeah, good question though. It's easy to think because everything up to this point of time, N was minus 1, not this time. Okay, anybody got an S3 answer? Maddie, what do you got for S3?
I got 226.88.
Very, very close. I might have screwed up. I had 226.68. But you and I are that's similar to what you said, right? Yeah, okay. All right, so what the heck's going on with this question? Because it's saying after 3 tablets, this is how much is in my body. Well, let's try to think about what's happening in my diagram up above, right? So pill 1 I took was 200. When I take my second pill, which is in green, my first pill reduced to 224. So in my body, I have 224 at this point. We got to kind of think what's happening to each pill. Now the green pill, by the time I take the third pill, it's gone down to 24. It's the same 3 numbers that keep coming up and up. So if I add these, I should get my 226. Okay, and this pattern is going to keep continuing on and on. The next pill here is worth 0.35. And by the time I take the 4th pill, it's always going to be close to this much in my body. It's always going to be a little bit more than 200. So let's see if that's true. Go figure out S12. Is it close to 226? Did the medicine world just want us to have a little more than 200 every time we took this pill? And we'll see by solving S12. Yeah, Maddie, your 880 is right. Looks like just based on that column there. Okay, so it looks like in the medical world here that this pill is always designed to be in around 227 grams in my body when I take the next pill. That's the sequence the series is designed to do, just so it has a little bit more to make sure it does the job until you're done your pills. Until you run out of antibiotics is typically how it works, right? Okay, so again, I'll wrap up the class for you here. You're gonna have a hand-in assignment on 6.4. I'll just write this down for you. Okay, that's what we just did today. I'm gave you 6.1 and 6.2. I'm gonna give you some review stuff. If you want, have at her. It'll come to you in an email. Actually, I posted it in the stream. Okay. You have a quiz tomorrow on this. And then we learn our last concept after the quiz for this unit. And then we progress through another short quiz, a review, and a test Friday. Okay. This is up to you if you want to do these reviews. It's just to get you ready for that little quiz tomorrow. 6.4 hand-in is due at 10 a.m. tomorrow. It shuts down. Don't ask for extensions as some did. I'm not going past it. It's 24 hours or so to get it in. Okay. I'm going to stay on here until 11:40. If you have any questions, please jump in. This is not the best way to learn. It's also not the best way to teach, but we're stuck with it for another 9 days. So we'll do our best through it all. Okay. So 6.3, 6.4, I'm about to share.